Hi, it's Kathy from Fieldwork Connections. I am at the lookout on the way to Wentworth Falls in the Blue Mountains, just west of Sydney. And today I'm going to be thinking about fieldwork in a sandstone environment and different field tests that you might like to do with your students if you are in the Sydney area or the Blue Mountains area. The first thing you need to understand about an environment and the ecosystem around it is the geology. And in this video I'm talking about a sandstone ecosystem, and you can see behind me here we have lots of sandstone outcropping, and in the Blue Mountains area we have some Hawkesbury sandstone similar to what we find in the Sydney Basin, but also Narrabeen group, so sandstone which is slightly older, so it's about 240 million years old and a bit older than that again. The sandstone in this area has a very high quartz content or silica content, and I'll have a look at my grain size chart and use a hand lens as well to have a look at the grains, but due to the nature of what it is made of, it's up to 90% quartz grains, and that means that there is quite a large pore space. It's a very porous rock, allowing water to seep in, and it's also quite permeable, so then the water can flow through it, and then that has implications for the way that it weathers and then erodes. So here is Wentworth Falls. And when we are understanding this sandstone environment and some of the landscape and landforms that are within it, if we were to link this into Year 7 or Year 8 geography in Stage 4, you can see the beautiful plateaus that are formed and the deep valleys. And that all comes back to the sandstone that I was talking about, having the porosity and the permeability, which allows the water to seep down through cracks and move through the rock quite easily. It then will physically weather the rock to deepen those cracks where we have waterfalls, but also chemically weather the rock depending on what is dissolved in the water as it moves through those cracks. As we go down the path, there's this beautiful area of overhang, and this is geologically because the rock has changed from sandstone to a shale, and they call that a shale lens within the sandstone, and the shale weathers more quickly than the sandstone and then erodes. So this finer grain just here has allowed the harder rock of the overhang to be above it, and then the almost cave formation below it. So this is the finer grain shale, or maybe even mudstone or siltstone, and then as we look up above us we can see that Narrabeen group sandstone with a larger grain size in it. So here we can see weathering and erosion in action as the water is dripping down through the cracks in the sandstone above to this layer of shale where it is eroding out the softer layer and creating this beautiful grotto that we can then walk through on the way to the falls. Whenever I find ripples in the rock, it reminds me of the depositional environment that this rock formed under. So you can imagine 240 million years ago, this was a riverbed, and those ripples were forming, and now they have lithified and turned to siltstone or sandstone. Two female lyrebirds, a mother with its baby. Very special to see. We've almost made it round to Wentworth Falls and the creek just above the falls, and I will show you some fieldwork equipment and testing around there. In a sandstone environment, you can do a pH test of the soil, which has weathered from the bedrock in the area. And the way I'm going to do that is by using this simple pH soil kit. And in the kit, you get some universal indicator, some barium sulfate powder, a little plate like this to put your sample on, and then there's a color change chart. So you take a small sample of soil, get rid of any of the leaf litter. So we've got a nice little sandy soil just there, and then we take our universal indicator, putting 2 or 3 drops into the middle there, letting it soak in, and then we just put our barium sulfate powder on top of that, and it soaks up the color change. And then we have to take the chart like this and we compare it to the color, and it gives us a number. So the soils that are more acidic are down the lower end of the scale, so 2 and 3 would have been quite acidic soils, whereas if we get up to the other end of the scale, we've got alkaline soils if it was purple. But you can see that this sandstone in this area of the Blue Mountains is quite close to 4.5, so we would call that slightly acidic. And you can then, after you've got the results from your soil sample, compare that to the creek water and see if it is similar. If it is similar, it's telling us that it is a natural undisturbed system, but if we find that it is different, it means that there could be something else influencing that, so maybe urban environments or runoff in the area. Now, another test that we could do in this area as well is we can look at soil depth using our soil depth spike, which has a cable tie attached like this, and a ruler. And so we just push that into the ground with the strength of our hand to see how far it will go in, push the cable tie down, and simply take it out of the ground and measure our soil depth off the ruler, making sure that all these results get recorded on a data sheet. And then we could compare those results from this location to another location as well. The third test that I have up here would be for soil moisture, and we use one of these soil moisture probes, just making sure that it is set on the moisture reading. You can see there's the dial that goes across the top and the needle will swing across. So we just push it in, not too far into the soil. We don't want to break it. You can see it just goes in a couple of centimeters. We have it set on moisture here, and you can see that it has the reading on here. I will read it across. The needle has gone over to number 2. So it goes from 1 all the way up to 10. So 2 meaning that the soil is not very wet. So there are a few tests that you can do in an area of sandstone environment, and then compare them to maybe a few other areas around. I'm going to do a water pH test of the freshwater creek that's running through this beautiful sandstone environment, so that I can compare it to the soil pH of the area. So I'm going to use this water pH testing kit, and I'm going to take the little vial that comes inside it and simply take a sample straight from the creek water and fill it up halfway, 10 mils, and then I'm going to take the universal indicator solution which comes in the kit, and I'm going to put 2 drops of that, 1, 2, into my sample. I'm going to put the lid back on, just gently invert it, and then compare it to the colour change chart. You can see that it's quite a deep purpley, almost brown colour. So I would say that it would be somewhere in between 7 and maybe even 6.5 in pH. Now, I'm not going to tip this out on the side or back in the creek. I'm going to dispose of that into a bottle and take it home with me. I'm going to demonstrate how to use a turbidity tube to measure the turbidity in this beautiful freshwater creek. And I'm using this turbidity tube. We are going to slot it together like this, very carefully, and then line up the numbers down the side. So in order to take our measurement, we need to be able to see the black and white marking on the bottom. And we then need to take our sample by lying it down in the water until the tube is full of water. And we have as much water in that column of water as possible. The next thing that we're going to do is look down through that column of water so that we can see that black and white marking on the bottom. If the water is quite clear, which it is today, I can look down through there and I can see that marking, so that I would be happy that the measurement would be less than 10 NTU. But if it was murky water, what I would need to do would be to tip it out to the next level, hopefully as accurately as possible. And then have another look through, and if at that point I could then see that marking on the bottom, the result would be 15 NTU. And that's how we test for turbidity in a creek. When looking at a rock sample, such as this piece of sandstone, I like to use a hand lens, which is a kind of magnifier. It's got the lens, it's got the piece that swings around. Some of them look different, but the way a hand lens works is that you hold it all the way up to your eye, shut your other eye, and then bring the sample up to your eye. And it allows you to see all of the tiny grains that the rock is made up of. That's if it's a sedimentary rock like sandstone. So when I'm looking at this in detail like this, I can see all those grains of quartz in there. And like I mentioned before, the sandstone in this area is about 90% quartz grains or silica grains. You can also then have a look at a grain size chart, which you can download from Australian Geoscience Australia, and it gives you the different sizes of sand grains within your sample. So if you can look closely, you can also get a sample of soil and put it directly onto the card like this, and you can see all the tiny little grains of sand up against, where was that sample I had before, up against the grain sizes there. So I would be confident in saying that this sandstone is medium to coarse grain sand. And on the other side of the chart, it tells you a little bit more about how well sorted the sand is. So if you're looking very carefully with your hand lens and you can see that there are lots of grains, small grains the same size, then it is very well sorted. But if then there's bigger pieces within it, then it's poorly sorted. And then the grains themselves, how angular they are. And this is showing how far the sediments have travelled before it formed a rock, because the further along it gets, the more worn off the corners of the grain sizes. So that is how I would identify and classify a rock sample or a soil sample in a sandstone area. It's been a great day in the Blue Mountains, and if you want to see more instructional videos about geography fieldwork, please follow along on my YouTube channel at Fieldwork Connections.